Hi, just a short video to answer some questions I've been getting. Anyways, it appears people like a lot of chit-chat, and I don't know. H.B. Parwell, did a video on him just subbing David Pose, so I guess I should do the same thing. Might increase my viewership a little bit. I just got in today a Bestech 2000 watt inverter. It's broken. I need another inverter like a hole in the head, but I don't know. I've spent my life fixing things. It's like Trivial Pursuit, except you either fix it or you don't. That's who's really smart. And what else? Oh, most of my system runs on a little microprocessor. These little nanos. They're only about $3. And they're so nice for doing control functions, and you really should learn how to use these. You don't have to do any complicated programming. A lot of it's really simple. If this, do this. So anyways, this gets my story. Last year I was hit by lightning. Hit the panels directly, and it knocked out a lot of stuff, and it took about 2 hours for me to get up and running again. Another 2 days to find everything, but it looks like I didn't. I have this little pump on the septic system, and usually you hear it going on and off in the power shed, and I just haven't been hearing it. And so I thought, well, yesterday I decided to diagnose what the problem was. So I looked at the control pin. It goes up to a FET, and the FET turns on the ground. So I tried hitting it to ground. I didn't hear the relay click. Tried measuring voltage, didn't have any voltage. So I opened up the switch box, and the 12 volt line to the relay was just open. So I connected it to power, and I always thought I had like an LED there in series, but if you can't figure out what I'm doing, think about me. I can't figure out what I did last year. So I hooked up the relay to 12 volts, and I hit the control wire to ground, got a big spark. So I got a dead short, and then I opened up the box again and checked the diode across the relay, and the diode was shorted. So I put a new diode in, put it all back together, tried it again, still wouldn't work, still didn't get any voltage on that pin. I'm thinking like, it's just a relay. How hard could that be? So I took it out and found the relay coil was open, and so then I put a new relay in. It still wouldn't work. I found out I had the FET shorted that controlled it, so I put a new one of those in. And then I'm like waiting for this thing to work, and it's not working. And I found out that when I replaced this microprocessor last year, and this is the actual one that blew up. You can see the hot melt glue that held it on the board. I had put the control pin for the FET on the wrong pin of the micro, so now it finally works. But geez, that was a long process. Anyway, back to building this control unit for heating. You got to have a capacitor bank, and I just built this yesterday. And you take a piece of wood, you drill some holes in it the size of the capacitors. If you have a table saw, you cut a slot in, and you can run 2 bars of like number 14 copper wire from some old house wiring, and hot melt glue it in. And it's a nice clean little unit. And you can put some plastic on the bottom. I mount against wood, so it's not a big deal. But yeah, I've seen some people do some pretty ugly things for capacitor banks, and I think this looks pretty nice. Okay, on the board, people have been asking about replacing the FETs with higher voltage, and you can do that. I recommend a 110 N15. And that's 150 volt FET. It's 110 amps. It's cheap. You want the on resistance low. You're not putting 110 amps through it. and if you did, it would burn up. But it's how they rate these things. But what a high current FET will have a very low resistance going across it when it turns on, and it won't do any heating. My system, I have two of these heaters. Mine only draws about 5 amps because I don't have a really good heating element. It's not low enough resistance. And these don't even get warm. FETs are cheap. They're plentiful, not hard to get. And there's no reason to have things heating up. So, I suggest a bigger power FET. And most of these boards will come with 3205s, which are 55 volt FETs, which aren't really good for much anything. As a 300 watt inverter board, it's a better FET, but not for what we're doing. So you're going to have to pull these out. And what I suggest is when you try to pull them out, go in there with a wire cutter and cut this center pin. And that'll give you 2 pins, and it'll rock out pretty easily doing that. And then, stick a pin while the solder is still hot, and you can make the hole. It's best just to go through with a small drill if you have one. But here's the problem: if you get up to higher voltages, normally they put the FET in a triangle, and that gives you much higher spacing. These, they put them right in a row, and this spacing is kind of tight. And if you're up at 120 volts and you're not very good at soldering, these distances can be really close. And given a moist day or just bad circumstance, you can short out and burn up the board. And I suggest these FETs connect through the tab too, and this heatsink has these screws. It does a double pin to the. There's no reason you really have to solder it there. So I suggest after you pull out the pins, you just cut across here with an X-Acto knife, and you should be able to peel up the center pin, and that'll give you a lot of clearance. And for a little extra safety, because a lot of times you're putting these down in basements, moist conditions, they'll get dust on them. Go over with some clear fingernail polish after you are sure the whole thing works. But get in there with a magnifying glass and make sure you have clean spacing. Knock off any rosin. Some rubbing alcohol will clean the trace. Just be careful. And when you put the new FET in, just cut it off at this thick section. Now, some of these boards are not easy to find anymore. They've come with a new integrated circuit, which is a 14-pin. It may be a 4153, which is another version of this. I don't know. I haven't bought any. I just ordered one board that's supposed to be this standard version, and who knows what they'll send me. They might send me the 14-pin chip, and I'll come up with ideas for that later. But you don't really, if you're going with high voltage and you have to remove the FETs anyway, you can make this on a little perf board. I have this was a piece of old obsolete board. It was bare, it wasn't populated, and I made the little circuit on here. It's not that hard. It's not that many parts. Let's look at it a second. If you take the FETs off here, the only thing you're adding is these 4 resistors, this resistor, that capacitor, and this. These are the things that would normally be on the board. And so you might as well build the whole thing, because you're going to have to put this stuff in there. Now I've done 2 versions of these. One is with a transistor. The transistor operates on the timing capacitor. When you get voltage here, it shorts out the capacitor and it turns this whole circuit off. But you can do the same thing with an opto-isolator, right where these 4 positions are, just like this. and it'll work just the same. That's what I did with this board. And if you're doing a circuit board, you know, if someone wants to build this and sell them and make money, you know, you have my blessing. You know, a lot of people do CAD, and they're good at CAD, but they're not good at circuit design. This is a perfect application for them. So these opto isolators, you know, I buy them for 3 cents each. Of course, you know, I buy things in quantity. And this opto isolator can be found in any little wall wart that's you know, got a little bit of age to it, because a lot of things are going surface mount now. But if you find a little device that's just 4 pins, chances are it's an opto isolator. It's not too critical. The TL431 is also found very close to this. If you have an old VCR, any of this stuff, I hate to see you people spending money, you know, because a lot of times you're ordering parts in small lots. You're paying more for shipping than actually the parts themselves. So, you know, any little capacitor across here, 0.1s are very typical in circuits. Here's the TL431. You know, a 10K is a very common value. You know, it can be from 8 to 12K. You know, a lot of the resistors, the diodes, even the LEDs, you can find on some old junk boards. So you might want to try just getting a little perf board. Now, you know, this looks nice. You get the terminals and everything else. And so if you have a small system, you know, I'd say go with this. But if you're going to be, you know, doing a kilowatt or more, or even 600 watts, you know, you might as well just build it yourself. So that's the message for today. And like, I don't like doing this any more than 600 watts. You know, but that's just my personal feeling about things. If you get above 600 watts, you don't want to go with a PWM circuit running off capacitors. But there's no real reason why you can't do that. You know, if you have a FET with enough current and enough voltage, and you have enough capacitors, you can drive this thing. So that's the message for today. And when you're doing an output by yourself, you know, you can just have these 2 FETs, piece of number 14 wire, connect them together. You always have to have a gate series and a resistance. You always want to have a pull down resistor so that when you power off, the gate is brought to 0. So this and this are a system, as long as you put a capacitor bank with them. And this is not hard to build. So thanks for watching. I'll get more theory later.